Alright, continuing on our proving geometric figures. On your assignment, make sure you've shifted over Q and R left one. Um, yeah, just typo on this assignment. We messed it up, and so move those both left one. And now get the coordinates for your points. They're going to be really helpful. Okay, once you have those coordinates, you can get to work on getting your side lengths and slopes. I'm going to start with getting SP, the distance from S to P. P is far to the right, so that's my x1, y1. So on your distance formula, you need to put -3 minus -4, square that guy, and 5 minus 2, square that guy. You're looking at 3 minus -4 is 1. Square that, you got 1. And 5 minus 2 is 3. Square that, you got 9. So SP is the square root of 10. That's the distance. And so something to note, that rise over run part, as in the slope of SP, is the rise is 3, the run is 1, so you have a slope of 3. And if you look at RQ, the slope of RQ is actually the same thing. It's 3 over 1, which is equal to 3. And since you have that, RQ, the distance from R to Q, is also the distance of the square root of 10. And if you really want to calculate that out, you're really looking at 3 minus 2 squared plus 3 minus 0 squared, which is that guy right there. Okay, so we have RQ and SP being the same distance, and their slopes are the same, so that's pretty convenient. If you now look at PQ, Q is the rightmost one, and so when we're filling out our form here, Q is going to serve as our x2, y2, so we're going to get 3 minus -3 squared plus 3 minus 5, square that guy. 3 minus -3 is 6, square that, you're looking at 36. 3 minus 5 is 2, square that, you got 4. And so PQ is the square root of 40. And if you look at the slope for PQ, that's a hideous looking Q. You can count down 2 for your rise. So that's -2 going down 2. And going over to Q is 1, 2, 3, 4, 5, 6. 6 to the right. And so it's -2 over 6. Which reduces down to -1/3. And something to note, going from S to R is a similar story. Down 2, right 6. And so they share that same slope and the length of the slope. And so SR is the same distance as PQ, which is square root of 40. And the slope of SR is going to be the same, -1/3. Okay, so we have some really good information here, and we can use that to get our information about rectangles. Okay, so now we have our slopes and our side lengths. We can write up our little explanation on how we know it's a rectangle. So in order for your shape to be a rectangle, the opposite sides need to be the same length and parallel to each other, and they have to meet at right angles. So in our little explanation here, we should include something about how they meet at right angles. And the way you know that these at these angles here are all right angles is because they're perpendicular to each other. And how you know they're perpendicular is you look at the slopes. We got a slope of 3 and a slope of negative 1/3. Those are opposite reciprocals, which is our definition for perpendicular. And so, in our little explanation here, we can write out since SP is the same distance as RQ. That should be a better Q. SR is the same thing as PQ. SP is perpendicular to, that's what that little symbol means, SR, and I'm going to put here in parentheses because they are opposite reciprocals. Oops, I don't need two S's. SR is perpendicular to RQ, and I guess we're not at end yet. There's so much stuff. Okay, SP is parallel to RQ, and SR is parallel to PQ. Quadrilateral. SPQR is a rectangle. Man, that's a lot of words there. Okay, moving on to 4. We'll go on from here. So on this one, it doesn't tell you what the what type of quadrilateral it is, and you're supposed to prove what type it is. And so we need to get the lengths and the slopes for each of the sides, and once we have that, we can make a decision. Is this a rectangle, rhombus, or just a parallelogram, and go from there. So on each of these sides, you need to get lengths and slopes and all that stuff, and I'm going to start with slopes. And I'm going to start with LE here. So slope of LE. I'm going to count. And so something to notice really quick. On all of this, it's counting by 2s, not by 1s. And so if I am going up a tick mark, that's an extra 2. And so I got 2, 4, 6, 8, 10, 11. So this goes up 11. And the run is 1, 2, 4, 6, 8, 10, 12. So you're looking at 11 over 12 for our slope there. And I want to also get, I just want to get all the slopes first. I'm going to get the slope of EF. And again, I need to count out my rise over my run. And so this one, each tick mark is 2. So I'm going down 2, 4, 6, 8, 10, 12. So that's negative 12 for our rise. And going right, well, I can really just count this out. From negative 2 up until 8 is 10. And the slope from T to F, I'm going to get that one next. I guess I can really just look at my coordinates to help me out instead of just counting it like I am. So T, the Y's go from negative 12 to negative 1, so that's a rise of 11. And from negative 4 to 8 is a run of 12. That one's pretty quick. And I need to get from L to T. L has a y value of 0, and then you go up to 12, so that's a rise of negative 12, so 0 to negative 12 is a rise of negative 12, and from negative 14 to negative 4 is 10. And so it's looking like we have two pairs of parallel sides, but they're not perpendicular, because negative 12 over 10 is not the negative reciprocal of 11 over 12. And so we're looking at a parallelogram right here, or maybe it's a rhombus. We'll have to get our side lengths to figure that out. But really, if we look at our slopes here, the 11 and the 12, that's change in y, that's change in x. If you remember, y2 minus y1, that is the rise. Okay, and so if we can just take our slopes here and use that to get our lengths. So if I want to get LE, I really just take 11, square that, add 12 squared. 11 squared is 121. 12 squared is 144. Add those together. I'm looking at, let me pause. That is 265. And so that's my length from L to E. And that's going to be the same thing as TF, because it has the same rise and run, the same y2 minus y1, and the same x2 minus x1. Okay, and so we have those distances, and let's get the distance for E to F. That's going to be the change in x squared, and I'm going to add the change in y squared. 12 squared is 144. 10 squared is 100. So the distance from E to F is the square root of 244. And since LT has that same slope, and it's just negative 12 over 10, it's going to also have that same length. And I totally forgot to reduce these down. And if you do, you're looking at negative 6 over 5 for both. So that's a little bit that I forgot. And so what we have here is lengths, and they're not equal. And so we don't have, so the opposite angle, opposite sides are congruent, and they're also parallel to each other. But we don't, that's all we have. And so this guy is a parallelogram for those reasons. And so I'm going to write it down here. Since EF is this, so from E to F, it's the same distance from L to E. That's not L to E. I need to get, sorry. This here is not LE. This is LT. My bad. Sorry, guys. So that means I need to fix that. LT. And LE is the same distance as TF, and the slope of EF is the same as the slope for LT, and the slope for LE is the same as the slope for TF. Quadrilateral. LEFT is a I wish I could spell parallel right. Parallelogram. Ta-da! And that's the end for that one.